Interesting. Now, before we start today's lesson, are there any questions over the homework? Any questions over the homework assignments? Yesterday, we just, well, since most everybody was coming in a little late, I gave you all a day to work on your missing assignments yesterday. What we're doing today is function operations, operations on functions. So we have f plus g of x. F plus g of x is the same as saying f of x plus g of x, adding the two functions together. F minus g of x is the same as saying f of x minus g of x. This here is f times g of x is the same as saying f of x times g of x. And here f divided by g of x is the same as saying f of x minus, or f of x divided by g of x. The only thing we have to stipulate with this one here is that g of x cannot equal 0. But that's true with any division. We can't divide by 0. Are you ready for the first example? Now with any of these here, for the first two that we're going to do addition. F plus g of x. So we want to find out what f plus g of x is. We're not going to focus on finding the domain, but once we find out what f plus g of x is, we're going to evaluate it when x is 4. Now f plus g of x is the same as saying f of x plus g of x, adding the two functions together. F of x plus g of x. And in this first one here, f of x is defined as 3 times square root of x. So for our function f of x, we can replace it with 3 times square root of x. And for this first one here, g of x is negative 10 times square root of x. And we're going to replace g of x with what it's equal to as well. Now we can remove the parentheses. So our 3 square root of x is just going to be 3 square root of x. Now since we're adding negative 10 square root of x, we can just write it as minus 10 square root of x. Well, both terms have the same radical and what's inside of it, so we can subtract the numbers in front. So 3 minus 10 is negative 7 square root of x. So f plus g of x is negative 7 square root of x. That's it. That's all we have to do for that part. Because it did ask us to find out what f plus g of x is. We did that. We did find it. We are not worried about the domain, stating the domain. Then evaluate when x is 4. So what that means, evaluate when x is 4. Exactly, plug it in. Find out what f plus g of 4 is. Now at this point here, we could go exactly as we did the last one and say f of 4 plus g of 4. Plug 4 into both and then combine But we already know what f plus g of x is. It's negative 7 times square root of x. So here we can just use it and plug 4 into it, giving us negative 7 times the square root of 4. Well, we can take the square root of 4 nicely, and we can do it by hand. Or we can say negative 7 second square root of 4. And get negative 14. So f plus g of 4 is negative 14. And that's it. That's everything we have to do for this. Questions on any of this here? Are you ready for the next one? So again, we're given f of x and g of x. F of x is 5 square root of x. G of x is negative 8 square root of x. We want to find f plus g of x. We're not focused on the domain. Then evaluate when x is 16. Well, for us here, f plus g of x is the same as f of x plus g of x. Now we can replace f of x with its function, which is 5 square root of x. G of x is negative 8 square root of x. We can drop the parentheses, so we have 5 square root of x plus negative 8 square root of x, or we can say minus 8 square root of x. Negative 3 square root of x. Since they both have the square root of x, they are like terms. We can add or subtract the numbers in front. If they weren't, then we couldn't add or subtract. So our f plus g of x is negative 3 square root of x. Questions on any of this so far? Now we need to find f plus g of 16, because we found f plus g of x. Now we want to evaluate it when x is 16. So negative 3 square root of 16. And again, just like before, we could plug this into a calculator. Negative 3 second square root of 16 is negative 12. So f plus g of 16 is negative 12. Any questions on any of this here? We ready for the next one? Subtracting. So we're going from addition to subtracting these two functions. So we could start off with finding what f minus g of x is. F minus g of x is the same as f of x minus g of x. Well, f of x in our case is told to us to be this here, 3x cubed minus 2x squared plus 5. 3x cubed minus 2x squared plus 5. Minus, we replace g of x with what it's equal to. So x cubed minus 3x squared plus 4x minus 2. Now, for the most part, this is not any different than what we did with addition, except for the sign in between the two terms is minus instead of plus. Now our first set of parentheses when we drop it is not going to change anything. It's still going to be 3x cubed minus 2x squared plus 5. However, because of this negative sign, or minus sign, everything in the second set of parentheses signs have to change. So our positive x cubed is now negative x cubed. Our negative 3x squared is now plus 3x squared. Our positive 4x is now negative 4x. And our negative 2 is now plus 2. We have to distribute that negative, apply it to each and every single term. And then we would combine like terms. So our 3x cubed minus x cubed is 2x cubed. Our negative 2x squared plus 3x squared is plus x squared. We don't have an x term in the first, so we just put negative 4x. And last but not least, we have 5 plus 2 is plus 7. So our f minus g of x is 2x cubed plus x squared minus 4x plus 7. Any questions on how we found f minus g of x? Now we plug in negative 2. Every place where there is an x. So I have 2 times negative 2 cubed plus negative 2 squared minus 4 times negative 2 plus 7. And I think it's what? Minus 4 times negative 2 plus 7 is 3. And with plugging numbers in, it's very important to make sure to put the parentheses around it, especially with our negative 2 squared. If we just put negative 2 squared without the parentheses, this would give us a completely different answer. So that tells us that f minus g of negative 2 is 3. Any questions on any of this here? Let's do one more of these here and then we'll move on. So looking at this here, f minus g of x is the same as f of x minus g of x. So we're going to replace f of x with what it's equal to. So 2x cubed plus 4x squared minus 8x plus 4. And we're subtracting from it g of x's function, which is our 3x cubed minus 5x squared plus 6x minus 9. Now, we can drop the first set of parentheses. And since there's not a sign in front of the 2x cubed, 4x squared, negative 8x, and 4, we don't have to change any of the signs. But our second set of parentheses, we have to apply that negative to every single term, giving us negative 3x cubed plus 5x squared minus 6x plus 9. So we do need to be careful with especially subtraction to distribute that negative. But so when we combine like terms now, 2x cubed minus 3x cubed is negative x cubed. 4x squared plus 5x squared is going to be plus 9x squared. Negative 8x minus 6x is negative 14x. 4 plus 9 is plus 13. So f minus g of x is this here. Now we need to replace every x with -1. Now at this point here, we could plug this whole thing into the calculator. -1 cubed plus 9 times -1 squared times -1 plus 13 is 37. So f minus g of -1 is 37. Any questions on any of this here? What do we think of addition and subtraction of these functions? Now we're going to look at multiplication f times g of x. Well, this is the same as saying f of x times g of x. F of x times g of x. Well, just like we did before, we can replace f of x with its function, which would be x squared. And g of x is indeed the square root of x. Yeah. I will take this here. Now, this is going to differ from the book. So if you are looking or trying to check your answers in the book, they will differ. This is the answer that I will take. The textbook is going to differ because it's going to change the square root of x from radical to exponential. And the reason that they're doing this is because when we multiply like bases, we can have the exponents, which will tell us that we have x to the 5 halves. Well, x to the 5 halves is the exact same thing as saying x squared times square root of x. They are the same exact function. But I want y'all to leave it as just x squared times square root of x. It's not giving us a better answer or anything more than x to the 5 halves. They are the exact same thing. Any questions on how we found f times g of x? Now, well, helps if I actually put it in. F times g of 9 is going to be 9 squared times the square root of 9, which indeed is 243, because we can plug that into a calculator and get the answer. Because 9 squared is 81, square root of 9 is 3, 81 times 3 is 243. Any questions on this here? So f times g of x, same as f of x times g of x, because we're multiplying the two together. F of x, in our case, is x cubed. G of x is square root of x. Doesn't matter what the two are. Square root of x. Now, if it had been x cubed and x squared, we would need to rewrite it as x to the fifth. Yes, sir? Yes. For the most part, yes. Any questions on how we found this here? Now, again, with multiplication and division, follow all the properties of it. So with multiplication division, we do need to follow all the properties of our multiplication division with like bases. So if we are multiplying like bases, as long as you're not having to switch it out of radical form, follow those properties. So if we multiply two like bases, we have the exponents. So with this here, division, f divided by g of x is the same as saying f of x divided by g of x. And again, just like we've been doing up to this point, we're going to replace f of x with its function, which is 6x. We'll replace g of x, x to the 3/4. Whenever we divide like bases, x and x, we subtract the exponents. It is 1/4. So for this one here, we would need to simplify because we're not changing the denominator out of radical form. So we get this here. So f divided by g of x is 6x to the 1/4. Now f divided by g of 16, we're saying that we're taking 6 times 16 to the 1/4. So we're just plugging 16 in. And again, on this here, we can plug it into the calculator. We can say 6 parentheses 16 to the 1/4. And that is 12. So our two answers are 6 times x to the 1/4 and 12. Welcome. Any questions on any of this here? You ready for the next one? Almost? Okay. So we're looking at f divided by g of x, which is the same as f of x divided by g of x. Now f of x in our case is 4x. G of x is x to the 2/3. Now whenever we divide like bases, we can subtract the exponents. Now we can do the 1 minus 2/3 in the calculator, which is indeed 1/3. And that's it. Now, part of the reason we get 4 as a whole number is because the number in the bottom of the fraction with x is 1, yes? Now, if, say, it had been 9 with that there, then it would have been 4 over 9 x to the 1/3, because if the numbers don't divide nicely, we can leave it as a fraction. Does that make sense? And the same thing would have been true with multiplication. If we can multiply, we'll multiply the two numbers together. But for our problem here, we don't have the 9, because it's just 4 over 1, which is 4. Now we need to find out what f divided by g of 27 is. So we're saying 4 times 27 to the 1/3. Which ironically is 12. I say that because I believe the last one we got was 12 also. I think 12 has shown up a few times today. And that's more coincidental than it is anything else. Questions on any of this here? Because the rest of this is the exact same thing. It's not changing anything. We're just doing more addition and subtraction. Now, the homework is going to ask you to do two things. It's going to ask you to add. So you'll need to find f plus g of x and f minus g of x for the first two problems on the homework. And once you find those, then you will evaluate both for a given value of x. So for 3 and 5, because the first two, they give you, so if we'll, because at this point, we can flip over to the homework. So I'm going to change this just a little bit. So 3 through 9, so you're going to do 2 with addition, subtraction, 2 with multiplication, division. So 3 and 5, you will do f plus g of x and f minus g of x, and then evaluate those for the given value of x. So if you look at 3 and 5, next to each g of x, it does have an x equals a given value. So each one has a different value of x we're evaluating it for. 7 and 9, again, multiplication and division with both, and then evaluate it for the given value of x that is given to us. Okay? And with 7, even though it's not in proper form, you can still leave the radical on bottom of the fraction. You do not have to change it to fractional form and simplify from there.